Now we come towards the mechanical waves. Now when we use this term mechanical wave, we are referring to the sound waves. Sound waves are longitudinal waves in air medium, but they are transverse waves on the surface of water and in the bulk of and on the surface of solids. So sound waves are longitudinal in air medium, or sound waves are longitudinal in the bulk of the material, but on the surface we find that they are in the form of transverse or transverse waves, whether it is the liquid surface or the uh, liquid surface, or it is solid surface. Method of energy propagation in which disturbance propagates with definite velocity without changing its form is called mechanical wave. So in mechanical wave, we find that disturbance propagates with definite velocity. And we found that without changing its form. And the next concept is like energy and momentum propagates by motion of particles. So actually the particles move in the medium, but medium particles remain at their initial position or the previous position. Mass transfer does not take place. Propagation is possible due to the property of medium, that is elasticity and inertia. We can say that every medium has a property of elasticity and inertia due to which the mechanical waves propagate. Transverse waves are normally produced in a string or on the surface of water, and longitudinal waves are just produced, or longitudinal waves are mechanical waves in air medium. Now, what basically are the longitudinal waves? The longitudinal waves are those waves in which the particle of the medium and the wave, they propagate in the same direction. And transverse waves are those in which particle of the medium, they vibrate at 90 degrees to the wave. Now, mechanical waves may be of two types. I have just now given you the idea. That is, one of them is called the transverse and other is called, that is, the longitudinal. So transverse waves, as I have suggested, the particles move at right angles to the wave motion. So the particles of the medium vibrate in the direction perpendicular to the direction of propagation of wave. Now there are certain examples of the transverse vibrations, that is the vibration of string, the surface waves produced on the surface of solid and liquid, and they always move in the form of crest and trough. When the wave is moving or the progressive wave is moving, they move in the form of crest and trough. The upper half portion of the wave is called crest and the lower half portion is called the trough, and distance covered by the wave for one vibration, that is supposed to be the wavelength. And otherwise, if the propagation is continuous, then distance between the two consecutive crests or the consecutive troughs will be taken as wavelength. Similarly, we can define frequency, that is the number of vibrations made by the wave in 1 second, that is called frequency. If n vibrations are completed in 1 second, then one vibration will be completed in 1 over n seconds. So T is equal to 1 over n. Now, the important note is the polarization of transverse waves is possible, but for mechanical waves, that is longitudinal waves, this is not possible. Now we come towards longitudinal waves. You are aware of the definition of the longitudinal wave. As I have explained, that in case of longitudinal waves, the particles of the medium and the wave, they move or they propagate in the same direction. So vibration of the particles of the medium are in the direction of wave propagation. Wave propagation means energy is propagating. For example, the sound waves or the waves in gases. So if we consider the gases, that will be called a bulk medium. So sound waves are longitudinal, that is in air medium as well as gases. Wave proceeds in the form of compression and rarefaction. So that's more essential to explain what is compression and what is rarefaction. Well, when we consider a tuning fork, we find that in the prongs of the tuning fork, the vibrations are longitudinal, but those vibrations are communicated to the air medium as the uh, transverse uh, progressive wave. They are moving in the form of crest and trough, or sometimes we say that the vibrations communicated by the prongs will be in the form of compressions and rarefactions. Compression is a zone of high pressure, high temperature, and high density. The waves are very close, or the particles of the medium are very close to each other. And in rarefaction, the particles are slightly away from each other. So it is a low pressure, low temperature, and low density zone. Now, at the places of compression, we find that the pressure and the density are maximum, while at the places of rarefaction, the pressure and density are minimum. We can include temperature also. That compression, temperature is also maximum of that region. And in rarefaction, we find that the temperature is not as high as in case of compression. Now, there is certain distinction between the radio wave and the sound wave of the same frequency. Let us assume that the frequency is 15,000 hertz or 15 kilohertz. Now, when we speak that radio wave has a frequency order of about 10 to the power 13 hertz, whereas the order of wavelength is 10 to the power minus 5 meters. They, they propagate, or they are used for radio communication, where sound waves, they are not used for radio communication. Sound waves are supposed to be the audio waves, and their frequency varies from 20 to 20,000 hertz. And that is what the human being can respond. But radio wave frequency cannot be responded directly by the human eardrum. So, sound waves require material medium for the propagation. So, there are certain points we can distinguish the sound wave from the radio wave. Sound waves cannot travel through free space while radio waves can. So radio waves require no material medium for propagation, whereas sound waves require material medium for propagation. The sound waves can propagate through solid, liquid, and gases. The speed of sound is 332 meters per second, and this can be calculated with the help of Laplace formula, which we will further discuss later on in the next context. And the radio waves, their speed is 3 into 10 to the power 8 meters per second, that too in air medium or uh, in vacuum, that is in the free space. And this can be calculated by Maxwell's equation. Now, with the rise in temperature, the velocity of sound increases while that of radio waves does not change. So, there are various effects on the velocity of sound, and those effects are not valid for the radio waves. And radio waves are normally transverse and they move in the form of crest and trough, whereas sound waves move in the form of compression and rarefactions. So, the effect of temperature on the velocity of sound, that is Vt over V naught, is equal to square root of T over T naught, that is velocity is directly proportional to square root of absolute temperature. However, pressure has no effect on the velocity of sound. So, next is sound wave can be detected by the human ear, as I have explained earlier, and the frequency must vary from 20 hertz to 20,000 hertz, and this frequency is known as the audible range. Sound waves can be detected by human ear if its frequency lies between 20 hertz and 20,000 hertz or 20 kilohertz, while radio wave of any frequency cannot be responded by the human ear. Sound waves can never be polarized, excluding the transverse mode in solids, while the ratio, that is not the ratio, rather we can say the radio waves can always be polarized.